All right, how's everyone doing? I think we're gonna wait like an extra 5 or so minutes just for more people to join, and then we can start the lecture. Awesome. I noticed many more people join. Let's just give it a few more minutes because we have a lot of time for this first part of the lecture today. All right, let's get started. Yeah, I just thought I'd wait a couple minutes for some more people to join, but I think we're at a good number now. So I'm going to start just by sharing my screen, and if everyone can let me know if they can see my screen. Okay, perfect. Awesome. So we're going to start our lecture off with a bit of a conceptual review of some of the things that we covered over the since Monday before proceeding to our next concept. And can everyone hear me all right? Because I'm not sure if my mic is like properly picking up audio. Okay, awesome. So I think we'll start with data types because this did come up. What sort of data types are we working with? So there are three main data types that we need to worry about right now. We have numbers. I'll just call it number. We have string, and we have Boolean. Can everyone give me some examples of some numbers? Perfect. Yeah. So like 1, 2, 4.5. Yep, for sure. That's a number. All right. Awesome. So seven. Okay. Well, we will seven greater than five. Okay. We're gonna cover that. So can everyone give me some examples of strings? How would they actually represent a string? Perfect. Right. So, and also, I think the most important thing when we represent strings, we need to give it those quotations. So you can either use double quotations or you can use single quotations like I'm doing right here. See, double, or I can use single quotations as well. So that's all right. No, both work. Yeah. But you have to make sure that you use the same type. Like if you're going to start the string with a double quotation, it needs to end with a double. If you're going to start with a single, it needs to end with a single. Yeah. All right. Can everyone give me some examples of Booleans? Exactly. So true, false, and then you know what I'm actually also going to put here because this came up in one of the examples. 7 greater than 5 is actually a Boolean because this will evaluate to something. No, invalid is not a Boolean. Yeah. So the only, and not 0 and 1 either. We be very specific here. A Boolean is only true and false. That's how it's represented. Is that clear? It's just Boolean is only two, there's only two like values that fit into it. Well, so that's the thing here. You have to be very careful when you do that. So when you say 7 equal 5, you have to use the two equals or the triple equals. Yeah, any conditional statement. So 7 greater than 5. The checking if 7 equals to 5, but you have to do with 2 or 3 of the equalities, not 1. Because this will evaluate to false, and this will evaluate to true. No. So and or are not Booleans. Those are operators that we use. Yeah, and we're going to go a little bit more into operators later. Right. So the difference between, let's say, and I'll show this here. If I do this, that's one thing. If I do this, all right, this is actually a really good exercise. These are not the same. This and this. Now these both evaluate. Not quite. So triple equals is actually, it's a hard check. Yes. So yes, that's true. So this first one, actually the first one is true. The second one is false. And the first one is true because the two equals is a less like restrictive check. Because 2 equals will just check the 2 equals is just going to check if it's not going to check the data type, right? So notice how this is a number and this is a string. So even though these are different, our interpreter is pretty smart. So with the 2 equals, this will still be considered equivalent. The string 7 and the number 7. Now the 3 equals, as we can see here, these 3 equals, the number 7 and the string 7, these will not be considered equal if you use 3 equals to check. No, so the first one, here, so the first one, this is true, and this is false. The first one is true. No, it's not false. So the idea is, yes, it is comparing these, but 2 equals is less restrictive of a check than 3 equals for an equality comparison. So even though these data types are different, this 7, you can almost think of it like the 7 that's a string can very easily be converted into a 7 that's a number. And so this double, no, it's different with, so let's not go with, let's just stick to this example, and let's not think about triple ands. Yeah, so when there's 3 equals, I guess the best way to think about it when we have 3 equals is that we're not only checking for the value being same, but we're also checking for the data type being the same. This is a string and this is a number. The data types are different, so a triple equal would consider this, like this would be false. A double equal is not as restrictive of an equality check. So it will not check for the data types being the same. Number and string. Exactly, yeah, that's a very good summary. The triple equal checks values and data types. The double equal only checks values. And JavaScript is pretty smart, so it can sort of be like, okay, even though this is string as a 7, the value is kind of the same because we could very easily convert this. Yeah, so I'm gonna highlight that. That's a very good check. That's a very good summary of that concept. So is that clear? This idea, I guess, are data types and also these here. Okay. Yep, Sawa, I see you have a question.
Yes, Alim. So of the 2 examples, the triple equal sign or the double, which one is an example of a Boolean?
So a Boolean would actually be like what the output of this, because if we were to actually, like if we were to assign this to a variable, the outcome of how the computer evaluates this would be a Boolean. Because notice how I put true here and false here? So once this is evaluated, this would turn into true, like this true. And once this is evaluated, it would turn into false. It's very similar to these because, you can almost like these are also comparators in the same way that greater than is here.
Right.
And this,
but those are
yeah.
They're logical operators, but then we're looking at the response to determine if it's a Boolean, correct?
Exactly.
The value. Yeah. Okay, thank you.
Okay. All right, awesome. So with that said, yeah, because Boolean is only really 2 values, true and false. Now, of course, these do evaluate to Booleans when you actually give it to the computer. We can look at that really quickly. So let's do this. Let's say example, and this is just temporary. I just want to see what this output is. So notice how this output is true. I'm saying that 7 is equal to 7, right? 7 double equals 7. And then whatever that is, whatever the output of that is, I'm going to assign that to example. This is a Boolean. So a Boolean gets assigned to this example. And we can even see when we console log that out, we get true. And let's even do this here. Type of, let's check the type of this. The type is a Boolean. I hope that's clear there. Okay, so moving on from that, let's also think about if statements, because I know this was something I'll just very briefly sort of, and we'll go into some examples of these as well. Yep, if, so very sort of generally, we will have for an if statement, I'll just put this in blue, have if condition, and then we have something here. The idea is that this condition, whatever we write, this condition will evaluate into a Boolean. It should evaluate into a Boolean. Now it could be, 7 greater than 5, 7 equals 5, or it could be some really complicated long thing. But the idea is whatever it is, the computer will be able to turn that expression into a Boolean. In the same way here that the computer turns this into a Boolean. So that's the idea. Yeah. So this condition is either going to be true or false. Now for the if statement, let's just worry about the true. If it's true, then we enter this block right here and we run the code inside of here. So this is what happens if it's true. If it's false, so that's when the if else statement comes, because now we can have some very specific behavior if it's false. And we'll go into more examples here. Okay, so we have, here's our true block, and now, even I think maybe color code this as well, so it's a little bit easier. We have our true block here, and our false block here. So now, what happens is that this condition evaluates to a Boolean, true or false. If it's true, we enter this block here. If it's false, we go into the else block that we specify here. So I hope that's clear so far. Okay, awesome. Yeah, definitely. Everyone, do let me know in the chat with yes or no if things are clear, or if anything I need to explain a bit more. Yeah, so it is mandatory. The condition will always evaluate to true or false, or something that are yeah, it'll evaluate to true or false. Now, one thing I should mention, because maybe some people are thinking, if this if statement, what if this condition's false, right? Just if we don't even have the else. So what happens here is that we would just skip this block and we would just go here, whatever, and we would just, the code would keep executing whatever continues after that. Right, so, okay, so this double equal, I'll just clarify. The double equal operator is a very loose equality comparison. And what it does is it checks if the values are the same. Now, 7 as a number is actually the same as 7 as a string here, because essentially what JavaScript can do is it can convert this string into a number, and it'll notice that that's the same, and it's a very loose equality operator. Right, that's just because JavaScript, our interpreter, can convert this string. Remember when if we pass the string 7, the string 7 into number, it can easily convert it into 7. So it's just these are considered the same according to the loose equality operator, which is the double equal. In a triple equal, these are not considered the same because the types are different. Because this is a number and a string. So you can think of it, it's sameness according to the operator that we're using. This is a double equals and this is a triple equals. So yeah, for if else statement, it's always a true condition and else is false. Yep. And we'll go over some other examples, like you can have multiple conditions, but we'll cover that a little bit later. And why there is a this before else, I mean, that's just sort of the syntax. That's how we separate this from everything outside of it. Okay, so the meaning of the double equals, it's a loose equality comparison. It's not like how we think in English of two things being equal. It's just how sort of we can tell the computer to do a very loose equality comparison between the number 7 and the string 7. And because the string 7 can be easily converted into a number, that's why this loose equality operator will say that these are the same. So this is like the computer saying it's the same depending on what metric it uses to judge two things as being the same, and how, in this case, how loose or how strict that metric can be for equality. It's not like what we're thinking in terms of English language or just human languages in general of things being equivalent. All right. How's everybody doing so far with that bit of review? Yes, so
So basically,
it will do this.
so basically, it's allowing us to in the double equal one, it's allowing us to compare two values without needing to convert it. Really, you know, the way we were converting it in the guess-through game. So we don't really need to convert in certain cases. We could use a value which is, for example, we are inputting a value and it is coming in as a string, and we can just compare it with a number, right?
Exactly, yeah. So like maybe remember in that number guesser, maybe I didn't even need to do
The conversion.
the conversion because I could have just used the double equals and save that time. Exactly. Yeah. So that's a good point. Yeah. But generally, it's good convention to use a triple equals. It really depends on what we're trying to do or what the use case is or how strict we want to be with our program. Awesome. So with that being said, let's continue to some
Sorry, Aleem.
examples. Oh,
Can you
yes.
repeat that with the number guesser? You said instead of doing the conversion, we could have used a triple equal sign?
Right. So in the number
Okay.
guesser, we
Yeah.
converted, and I'll just bring it up here. So notice how here whatever value we put in,
Right.
we turn it into a number here.
Right.
Now, we didn't actually need to do that because what we could have done is we could have just used, well, I mean, even here I use a double equals, right?
Right.
And so, yeah, if we just used the double equals, we could have compared the number that's inputted as a string with the actual number that our computer guesses, and that would have been totally fine. So we didn't actually need to convert it into a number if we did use the double equals. If we use the triple equals, then we would have to convert that string into a number to handle that. So I hope that clarifies that concept.
Thank you.
Okay, so let's get to some examples because this is going to be the sort of the meat of the lecture is going to be these examples. So the JavaScript, like with the double equals, string, it knows how to do that. We don't need to worry about how it does that specifically. But yeah, so let's do some examples. And I think this is a good example. So I will let's think about what is happening let's think about what actually prints the console if I type in banana here as a string. Can everyone tell me what prints the console? Like the exact sentence that prints the console if I were to put the string banana into my fruit here and run this code. Perfect. Okay. Does everyone see why that's the case? So exactly right. So you can almost think of it like this replaces the my fruit when the computer starts evaluating it. And then we're comparing the string banana. Is it equal to banana? And it is. So then this becomes true, becomes the Boolean true. And because that's true, then we run this block of code, and then we're done. The example's done. Yeah. And if I were to put something else, like if I were to put apple, yes, it would run the last one. Your favorite fruit is something else. And again, that's because, let's say, okay, I'll just go with apple. So the apple would go here instead of it'll replace my fruit. And then we would check apple double equal banana, right? That's an equality comparator. And they're actually not equal. So that this condition would evaluate to false. That would what this condition would evaluate to. And because of that, we would then go into the false block of the code, and this would run. So is that clear? This sort of idea? Okay, good. Because we're going to be going through some examples, and I think it's a very useful exercise to just like literally by hand look through these conditions and just practice how the like put your mind in the mind of the computer and how it will evaluate these. And we're going to do a few more examples of that as we proceed. So let's think now. This is a little bit more complex, but I think this is a good example. So let's put my number at, let's put my fruit as apple. Actually, let me make this red so it's a little bit less confusing because apples, well, many of them can be red. And let's say my number is 3. Yeah, so the condition part of the if statement, like this portion, will evaluate to a Boolean. All right, so what happens in this case? What prints to the console? Exactly. And let's talk a little bit about why that happens. So, and I think the best way to do that is to, we're just gonna take this outside here, right? Because at the end of the day, it's just a condition that we're thinking about in this context. So apple, this becomes apple because the computer will sort of assign the value to the variable. And this is 3. Let's think about how these evaluate. Apple equals banana. So this is false. So this becomes false. And then this is true. 3 is equal to 3. But we have an and operator. This is saying and. Now, false and true is false. Because if we have an and operator, the only time we get something true when we're comparing two Booleans with an and is if both are true, true and true. True and true is true. Anytime there's a false, it'll be false. So this is false. And that is why this is false. The whole thing is false. And that's why we enter this block here. Yeah. So is that, does anyone have any questions about how that happens? Okay, awesome. So banana is not false. Banana is not false. It's the condition that evaluates to false, right? Banana is just a string here. But if I put, right here, I put apple into my fruit, right? Because my fruit is just a variable that holds a value. So when the computer goes about actually evaluating this condition, it will put the string into my fruit and it'll compare, it'll say, is apple equal, right? Double equal, is apple equal to banana? No, that's false because there are 2 different strings. right? And then it does the comparison with the number. Now that, yeah, you don't need to define banana because banana is just a string that I'm just saying, is my fruit equal to banana? Like the double equals. I'm not assigning banana to my fruit. I'm saying, is whatever string I put as in my fruit, is that string the same as the banana? This banana string. Yep. Okay. So it seems like everybody has got that. Let's move to the right. So Abdulrazak, that is true. That is true, but well, it depends. Like here, I've defined an else case. So if it's false, I answer the else case. Otherwise, if I don't have an else case, yes, it will just continue here. But all right, so let's continue to this example. It's a little bit more going on here, but let's see, what will the terminal print out if I put mango here as my fruit and I put the number 4? What is going to print into the terminal? What will this program output? I'm actually going to also have this on, I'm going to make this on the side as well, just so we can run through a bunch of examples, because I think this is going to be a good example. It's just easier if I just copy and paste that. Okay. So what it actually outputs is mango. I saw a lot of different, okay, maybe some people changed their answers as well. So the reason why it outputs mango, let's actually look into this. So let's like, we'll go through each of these conditions a little bit more in detail here. So I'm just gonna take this out here. And take this one out. And we'll do a few more examples of this one as well, because I think this is a good example to go over. All right, so let's see what happens if, so this is, my fruit is mango, and this is 4. Does everyone know this would be false, right? Because you're right, yeah. So because this is false, mango does not equal apple. And then 4 also does not equal 3. So this or condition is false. And if the or condition is false, we do not execute this block. We continue to the next one. So I remember in one of the office hours, someone asked about like if versus if and else versus if and else if, and I think that was a great question. I apologize, my brain was not working at that hour, so I couldn't give a better explanation. But here you can see like the main difference between if else and if else if is that with if else, we can only check one condition. But because one condition, if it's true, we go to true. If it's not true, we go to the else block. And if we want to check more conditions, we need to, it's a bit complicated. We got to put more things in that else. And there's a lot of nesting. But in this case, if we use else if, notice how we check this, it's false. So then we're now checking this condition here. So it's an easier way to write checking one condition and then another condition and then another one after that and so on, without having to like put more code inside other blocks and making things a little bit more complicated. So let's look at this one. So this is mango. My writing is pretty bad, but okay, I hope that you read. And then the number was 4, right? Mango, is mango greater than apple? So when we talked about, I remember earlier we mentioned something about like string comparisons. Right. So yeah, so you don't always need to check the alphabet code because you can always think of it like in the order of the alphabet, the letters get larger in terms of their number representation. So M, because A goes before M in the alphabet, because it's like A and then B and all the way up to M and so on, the number for A is smaller than M. So that's why when we first compare M and A, M is larger. So this thing becomes true. Then we check, is 4 equal to 4? Yes, that is true. So then both of these are true. True and true is true. So then we run this line of code, and then that's it. And then the program ends. So now I will ask the class. Awesome. Oh, yeah, Salwa. Okay.
Yes, Alim. So if that statement were false, then we would go down to the last block or line, right? And run that, or automatically it would be hocus pocus, correct?
Yes, so if that statement
Okay.
is false, we then proceed to the else block. Now,
Okay.
I think that with that being said, okay, someone missed, so lexicographical just means like how we compare strings. It's sort of like, it's a different way of saying in alphabetical order that we're comparing strings. So you know how like A in the alphabet, we have like A, B, C, and then all the way to, let's say, Z. So in that lexicographical comparison, because A comes before Z, if you were to compare A and Z, A would actually be less than Z because it comes first in the alphabet. So when we compare mango and apple, the strings, because there are like many letters in this string, we'll compare it letter by letter. So first we'll compare M to A. And because M comes after A, the M is larger. So then mango is larger than apple. No, it's not data size. It's just a representation. It's just how we represent the number or the letter in the how the computer will represent that data. So it's not actually, it doesn't have to do with letters, the data size itself. That's something different. It's not the number of characters in the string. It's literally just comparing like letter to letter.
Is it because of ST codes, right?
Yes. So yeah, but I think the best way to think about it would be this example that I just mentioned here. Also, just in future, I think it's good practice. If anyone has a question like during lecture and wants to unmute, I would appreciate just like raising your hand just before, because if multiple people have questions and like unmute at the same time, there might be an issue. So yeah, just do raise your hand, because then I think Zoom will automatically queue the participants, so I can just see who raised it first and just address it in that order. Yeah. So okay. So the next bit of this is I'm going to ask you guys to actually tell me what inputs could I give my fruit and to my number to console log out hocus pocus. And there's probably a lot of inputs, so we can check. So yeah, the rest of the letters of the words are not checked together. The rest of the letters are checked as well. So if the first two, like, if mango, if I had mango and like map, M and M are the same, so it moves to the next letter. Both of the next letter compare. And it just continues doing that. So see, okay, so I'm assuming, so someone wants me to repeat something. I'm gonna assume that's this. So what I want to get you guys to do is to essentially take these two variables and think about, and actually let me know in the chat, what input would you give it, right? And so for the string, my fruit, do use the quotations, and for my number, of course, a number. And think, what input would you have to give this program here to get this console log, hocus pocus? So my fruit and the number. Okay, I see. I'm gonna pick something random. Okay, apple and 5. Right, but which values would you put here to get to this block instead of any of the other ones? The hocus pocus block, not the mango block, or any other block rather, for that matter. So peach and 6. Okay, peach and 6 looks good to me. So let's try that. Peach and 6. So what happens? So automatically, so 6 is not, so let's just see here. I'm going to use peach and 6. So peach does not equal apple, so this is false. 6 does not equal 3, so this is false. False or false is false. So this whole thing is false. So we're going to go to the next one. Is peach greater than apple? I think it is. So this is true. Peach is greater than apple, but 6 does not equal 4. So this is false. True and false is false. So this condition's false. So then we move to this else block and we print hocus pocus. So yep, that works. And I see another one, strawberry and 2. Okay, let's think about that. So strawberry and 2. Strawberry does not equal apple. 2 does not equal 3. So we know that false or false is false. And sort of this, I think this approach is really good, like individually evaluating each condition. And then once those are done, then using these operators to figure out, okay, what's the actual output? I think it's a good sort of very systematic approach to doing these conditions, and it will be really helpful. So this is false. That's good. We go to here. Strawberry is greater than apple. That's true. But 2 does not equal 4. So this is false. True and false is false. So again, yeah, hocus pocus. Avocado and 6. I think avocado and 6 would work as well. Yes, because this would be false, right? And then avocado is bigger than apple. So even though the first two letters A are larger, the V, I'm pretty sure V is later in the alphabet than P. So the V is larger, and then avocado is bigger than apple. Okay, so that's true. And then what was the other thing you mentioned? 6. 6 does not equal 4. Okay, so this is false. True and false is false. And then we go here. So I think that there's some good examples. I see Marwa has raised her hand.
Yeah.
How can I help?
This is just to clarify. So basically any fruit right now and any number would give the hocus pocus response, like the log. And the only reason why like you're doing this is to explain the Lexa thing, whatever it's called, Lexa something, like the alphabet. Is that what I'm getting?
It's both, but it's also just to sort of give a more complicated example where the conditions will be a little bit larger than just a single comparison. Like there's an or, right?
Okay.
So it's
Oh,
partly
okay.
that as well, right? Or an and. So, and it's
Okay, so
also just
any
to get good, I guess, good practice with sort of step by step doing these evaluations.
so any fruit right now would work as long as it started with any letter after A.
It would depend on the number, right? Because we give as
Oh,
well,
okay.
right? So that's like seeing this condition, this would be
Yeah, like
true,
if the
but
like
then
for
it
the letter,
also,
yeah, for the apple, like for the fruit, any letter that starts with like after A and then any number other than 4. I might be wrong. I'm sorry.
I'd say test that out. So try giving a number. Um, sorry, maybe I'm misunderstanding the question, but I would say I'll also be like posting up these examples. So I think it's definitely will be good practice to try some different inputs and see if that works or not. Like you can try giving something that is not greater than apple and the number 4 and see what happens, or and do that as well. Sorry, I might not have understood the question fully. Uh, okay, no, that's okay. All right, so and don't worry, I will during the break when I will type up these examples and then like put this on Canvas so you guys can also like just test these and see different outputs and like what's sort of happening. All right, so let's continue. So okay, so we're going to talk now. We're going to sort of move on from our conceptual review and we're going to go into the next lesson on loops, but we're going to start first with some examples. And more specifically, we're going to talk about some real variables changing over time and some real world examples of this. And I'll talk about a few. So I guess one thing we can think about is, what are some instances in the real world where we would have to worry about things changing over time? So something that automatically comes to my mind is a bank. So my bank is RBC, right? I think many people here might have RBC. That's going to be our example. And so, whenever you deposit or withdraw money from your account, your balance changes, right? So an example of a variable changing in this context of RBC could be your bank account balance. So let balance, this is your bank account balance. Let's just say that is $100. So our balance is stored in a variable, and then every time there's a transaction that gets updated. So let's say I make a withdrawal of $20. So I would, if I want to represent that in this way, I could write balance equals balance minus 20. And what that's doing is this balance, like when the computer it'll look at this line, right? And it'll be like, okay, I'm going to put $100. I'm going to make a variable. I'm going to put 100 inside of that variable. So that's good. The computer reads that, it gets that. Now it goes here and it's thinking, okay, I'm going to reassign a new value to the variable that I already have. And to do that, okay, let's see. Okay, balance. So I'm going to take, what do I have in balance? 100. And I'm going to subtract 20 from that. So this is going to be 80. And so the computer is like, okay, I'm going to reassign 80 to balance. So now the balance is $80 after a withdrawal of 20. So that sort of, I hope that everyone, is that clear? Just feel free to write that in the chat. Okay. Now let's do a deposit. So let's say, good fortune strikes and you win the lottery ticket and you get $5,000. Awesome, right? So now when the computer sees this, it's going to be like, okay, now let's do a deposit and let's reassign some new value to balance, because balance already, we've already declared it here, right? That's what when we say let balance, we're declaring this variable. And here we're reassigning it. So the previous value of balance from the reassignment. So what does the computer put over here? I just circled this. I'm going to use a different color. What does the computer put into this variable that I've circled in yellow? Right, 80. Good. So we get 80. And then we are depositing $5,000. So now what we reassign to balance is 5,080. So I hope that, so that's just an example of a variable changing over time. We will be continuing with this like bank example in our labs. So I just thought I'd introduce that now. Yep, Eunice, I see you have a question.
Yeah, I was gonna say, if you put the balance plus like 500 and you put it on top of the balance minus 20, it would change, right? Like it would be, instead of like 580, it would be 480, like 4,980. Like you like you would add 5,000 and then minus 20, right? If you were to switch their places.
Yeah, so the order in which you do these things does affect that for sure. Let's actually do that right now. So I will actually, can everyone see what I'm typing? Let me just start typing. I'm going to put that in blue here. We'll do another example where we actually do it that way. Everyone can see that? Okay, perfect. Now, that's a good point. So you mentioned what if, so we'll use 500. So you mentioned like, what if you first add 500 and then subtract 20, right?
Yeah. Yeah.
Okay. We'll actually use 5,000. I'll just show that endpoint will be the same, but if I do balance plus 5,000, and then I say balance equals balance minus 20. The endpoint will be the same, but just the order in which it's done is different. And actually the value at like these particular points will be different. So okay, good, balance is 100. Now we reassign it. So this is 100, right? 100 plus 5,000. The new balance at that point in time is 5,100. So that's good. And notice that's like different than 80, right? Just because we've switched around the order at, in terms of how we're doing these transactions. And so at this point in time, the value of this variable balance will be different. Now we go here and see balance equals balance minus 20. So the balance is previously assigned as 5,100. We subtract 20, right? And now we get 5,080. And that's our final value. And like, yeah, you're right. So this is the same. And I will just circle this in red. Actually, let's just use white. This is the same as this at the end. Yeah. But like, this is different than that. And then, yeah. Yep, Sawa.
Sorry, Alim, I might be missing something. So, based on what we learned previously, I was under the impression that in the first line, when we say let balance equal 100, and then the second line, balance will take the value of 100. So then we would do 100 equals 120, which is 80, and then that would be a false statement. But I don't know if I'm confusing things here.
So when we do 1 equals, we're doing an assignment. And when we do 2 equals, then we do a logical like comparison.
Okay.
That would
Thank
be
you.
yeah. So it's like this 1
piece.
equals, we're saying, okay, let's change the value of balance and let's change it to this value. Let's reassign balance.
Okay, thank you.
It's kind of like what we do here, where we do here. Yeah.
Okay, the
All
1
right.
equals.
All right, Samina, I see you have a question.
No, I just had a comment. So just to add on to what she said, basically the value of balance is going into this part. Yeah, where the red dot was. Can you move the red dot towards minus 20? The other half, the left side. The
Oh, this
100
bit?
goes towards the left side, and then the calculation is done, and then it's moved into the right side of the equal sign.
Or you mean like this side here? Like once this calculation's done.
Yes,
Yeah,
and
then
then it
we
is assigned. Yeah.
exactly, yeah. So yeah, I think that's a good way to think of it. Like this left-hand side has the variable that we want to reassign, and this right-hand side is what value we want to assign to that variable. Yeah. Shazad.
I had a question. Can we see like how we would do this if we were to write it in code? Like
For
in
sure, yeah. Let's see what would happen in code. I'm just gonna comment this out for now. So let's say let 100, and then let's see number equals plus 10, console.log number. Now, I think later on, I don't actually have it running right now, but there's something called a debugger, and you can actually you can actually see line by line how the computer is reading your code and modifying data. But we will cover that. I think I'll try to get that in next week so then like we can sort of see these things in more detail, what's happening. But here is an example. Yeah. Notice before I do that, number is going to be 100 before I make that modification, right? So see, at this point in time, it's 100. That's why I print 100. At this point in time, it's 110. It's the same number that's being changed. All right. So with that being said, let's move on to the next example. So actually, I will move this slide I will cover that after because that's loops. So I think what we're first going to do is let me move this here. Okay, so yeah, let's take maybe instead of a 10-minute break, let's take a 5-minute break. Sorry, guys, but I don't want to go too far over our time allotment. The next lab is pretty straightforward, so maybe that'll take less time and we can continue with our lecture because I think getting to loops is pretty important, but we'll see how things go. So yeah, take a 5-minute break and then come back for the lab. And I'll give a little bit of an intro to the lab. I'll even show an example in the code of like a very similar problem to the lab problem that I think will help with that lab problem. So yeah, I guess we'll be back at 9:05. All right, we are back. That might have been a little bit over 5 minutes, but yeah, how's everyone doing? So we're going to start with lab 1.1. So let me share my screen just to show the lab. And I think before we get to the lab, what I will do, is I will also include an example, a similar example. All right, so can everyone see my screen? It should be this this slide with lab 1.1. Okay. So during this lab, what we want you to do is to, let me just find it here. What we want you to do is to make a program that simulates an ATM machine. So it will print out the total amount of money in your account. And the account starts off with a balance of $100. So the program should ask the user for how much money they want to deposit or withdraw. So that's a hint for prompts. The user will provide either a positive number for deposits or a negative number for withdrawals. And then the program will use that to update the balance and print the total amount. And I do know, I think it did come up earlier that I think someone mentioned that there might be some issues with Node and like prompt was not working for them. So I think that's fine. We know who that person is, so or who those people are. So if that's the case for you, don't worry about asking for user input. You can just assign a value to a variable and just have that be the user input. Yeah, exactly. You can hard code it. Yes. So what I will do to make this example more clear is I'm actually going to show a similar example that's a bit different. So we're going to use fruit as our similar example. So I'm actually going to code that right here. And I will also paste this in the chat. Let's copy and paste prompt. This is going to be our fruit example for lab 1. So that's for the prompt. And now let's think about this. So let's say instead of money, we have a basket of fruit, and user can either, or I guess, either take fruit out or put fruit in the basket. And we still want to display the output to the user. It's like how much fruit is left. Okay. So let's think about this. Let's just start with getting the user input. How much fruit do you want to add? So it can be a positive number, or remove, it can be a negative number from the basket. All right, so let me just check if I'm recording. Okay, good. So what do people think, what will the, regardless of what I put in, what do people think the type of the user input will be? String, okay. String. Okay, let's test that. Let's put -10. So like you're removing 10 pieces, let's say, right? So regardless of what we input, the type is a string. Okay, so the type is a string. So let's think about that. I remember mentioning earlier, we want a number, right? Because we're going to have some number of fruits in our basket. That's going to be a number. And so we either want to add to that or subtract from that. And earlier, there was something we could do this variable to turn it into a number? Feel free to write in the chat. No, we don't add the quotations. Yes, we convert it to a number. Now, one way to exactly, yeah. So there, more specifically, we will reassign. Remember, just in that example earlier, we will reassign to user input number user input. So what this is doing, I mean, I can scroll over it as well. So you can see how within brackets it says value any, and then arrow number. So it takes in any value and it outputs a number. So whatever we put in here, this will be converted in, this will be a number, and a number will be reassigned to the user input. Exactly. Yeah. Yes, Samina?
So basically, we are actually changing the data type as well, right? This way?
Exactly. Yeah. We're changing the data type, the type of the data, and we're also doing reassignment.
Yes.
I'm going to write that down. So we are changing data type of user input and reassigning user input as well to that new value that has a different data type. Exactly. Okay. Comment this out for now. And don't worry, like all this, like literally all the code that I have in the lecture slides, I will move it to this JS file during the lunch break, and I will have that posted up as well. Okay, so now we have that. Now let's think about this. Maybe we'll do it up here, but let's say, how many fruits do we want in this basket? Or rather, if everyone can tell me, how would they assign some number of fruits to a basket, the variable basket? So both declare the variable and initialize it, or assign some number of fruits to it, to this variable. It's very similar to the thing we did with the bank balance previously on the slide. So yeah, just feel free to type in the chat. Yep, so, oh, okay. Anyone have any ideas of how we would go about doing that? Declaring a variable and assigning a number to it. Okay, good. So that's pretty close. Yeah, so let would be the starting point of declaring a variable. More specifically, a variable that we want to be changed. Exactly, let num equals 8, for instance. That's a good example. So instead of num, let's call it basket. I see someone here mention doing this. You don't want to put brackets there. So that's actually not the right syntax if we were to do that. Let's put maybe 25 fruit in the basket. But you know what? I want to actually see what'll happen, because part of being a programmer is exploring things. So I want to see what'll happen if we actually do that. Maybe JavaScript is really smart and it can figure that out. But let's see what happens if we do that. Oh, perfect. Oh, interesting. Okay, awesome. And let's see. Okay, let's just do that. So let's also see the type of basket, if it interpreted that as the right number. Okay, so that does work. But it's good practice not to put those braces around that just in future. Okay, so we have 25 fruits in this basket. Now, we have 25 fruits in the basket, and we also have some number of fruits that we have gotten from the user input that they either want to remove, it's a negative number, or they want to add to this basket a positive number. So how would we update the fruits stored in this basket? This number stored in the basket, which represents the number of fruits we have stored. Any ideas? Yep. Right, so that is the right-hand side of what goes in our, yeah. Okay, so we would first start with, yes, Samra? I can see
Yeah,
Samra.
yes. My question is that why are we using like what's the difference why are we not using number in line 32? Like why are we using another line in line 33? Like user input is equal to
Um,
yes.
yes, that's a good question. So we're just doing that just to make it a little bit clear what's happening with reassignment. We could also put number here and just put, like you mentioned, brackets. I think the number guesser had that. We could also do that, and that's perfectly fine. But just this is also another way to do it. And this also just shows a bit more explicitly that
Okay, and
we
one more
are,
thing. So these user input on line 32 and 33 are these same? Like these are the same variables?
yes. So this variable user input, you can see if I actually like, if I select that, notice how this is also highlighted, but this
Okay.
has a different highlight. So this is the same variable. So the change that I make here in terms of data type, when I reassign it to user input, it's essentially it's overwriting the user input that I got here, that I gave a value to here.
Okay, so it's just an extra added step what you are doing. We can just do it in the same line as well.
Exactly, yeah. But if you do it on the same line, just do remember to have the brackets properly around
Okay,
the
thank
prompt. Sala, I see you have a question.
Yeah, Salim. So I was wondering if we're setting the value of the basket to 25, would that be the maximum amount someone can take? In terms of fruits? Or am I
Yes,
getting
that
myself?
would make sense because we don't want, you can't take more than that and have a negative amount of fruits. So you're
So we
right,
have to set a
that is
condition,
true.
right?
Yeah. I
Okay.
think for now we'll leave the condition out, and now we'll
Okay.
just have the rest of it sort of. We'll just make that assumption, and let's just hope the user doesn't try to take more fruits.
Oh,
All
okay.
right, Abdul Razak.
Can you please hover on line 33 and show me the difference between user number and the other one?
Sorry, line. I didn't
33.
quite catch that.
Yeah, I've seen you hover, but I did not see exactly what the compiler give
Oh,
for
for sure.
the variable 33.
Yeah. So let's just do this. So let's. Okay. So let's do it like this. So we're going to say the value of the user input. Then we're also going to have type, both before we do this number and then after, right? So before we perform the data type conversion and then after as well. And let's see what happens. What do we call the log? Just say 5. And notice how so first it says 5 is a type string. That's line 33. And then line 35, it says 5. And even notice that this 5 is now like yellow, whereas this one is sort of like an off-white color. Now here 5 is of type number. So I hope that clarifies sort of what this is doing and how it actually changes the value of the user input and the data type.
Okay.
User input. Okay. Samra, I see you have a question. Okay, let's continue. I will point these out, these console logs. Okay, so perfect. So I see many people answered my question. So this is how basket would update. It would just be basket plus user input. And I made a little mistake there. So yeah, We don't want to retype let because let is like a keyword. We use it when we want to declare a variable. The variable has already been declared here. So this is like we are reassigning a value to the basket. And more specifically, it's going to be basket plus user input. And I hope that makes sense. We're adding it, right? Because even if we put a negative value, if we just add a negative value, it'll handle that just fine. We don't want to put minus here. Plus. Then our last step is just we're just going to console log. We have then pieces of fruit remaining. Let's see. This is just another way of doing it. I can also just do a plus there as well. So I will actually change that to plus. And let's see what's going on now. So I want to add 10 pieces of fruit, 35 pieces of fruit. Instead of remaining, I will make it just fruit, right? Because it sounds a bit strange if we say we have fruit remaining and we're adding fruit. So let's say I want to remove 5 pieces. I would actually write -5. And now we have 20 pieces of fruit. Yes, Samra, I see you have a question.
Yeah, sorry. So, how the user is picking up the operation? Like, how can the user pick up the operation? For example, add or subtract. How would user tell that he or she wants to add or subtract?
We can go over that later. There's like a line, something drawn on my screen. I want to see, can I remove that? Okay. Okay, there we go. Yeah, so we'll go into, that's something that we can cover later. There are some other concepts we would have to
But
include.
in this particular case, because you are saying that how much fruit do you want to add or remove? So if user wants to remove, he or she should give negative number. That's what you are suggesting?
Yes, for this example, it'll be a negative number. But to have if you don't want that negative, there's some conditionals that would have to be added, and that's something we can cover later. But this is
Yes.
sort of like a very
For this, no, I understand. I'm asking just for this particular example. I thought maybe I missed something. Okay.
Oh yeah, no worries. Okay, so awesome. So I think, oh yes.
Sorry, Alim, I was wondering for this example, would it be possible to maybe include that in the prompt and tell the user if you want to remove fruit to put a negative response, or am I
Sure.
complicating things?
How much fruit do you want to add? I sort of did it here, or remove.
Oh, okay.
I'll just say here, I'll just say put a negative number.
Okay, I see.
As a response, yeah. So now that will be changed, and we can see here, put a negative number, so -1. Now we have 24 pieces of fruit. All right, awesome. So I hope that this example helped, because now we are going to, and let me just copy and paste this in the chat. I will also, put up the JS lecture. I will also remove the comment just so it is a little bit more concise. I see people have their hands raised, or do you still have questions, Samra? So, okay.
My hand is up just so that when we go into breakout rooms, maybe I can get some help with something.
For sure. All right. So yeah, let's do that. So everybody who still has questions and they want that addressed in breakout rooms, please do raise your hands. And I think now what we're gonna do is I will switch my screen to Lab 1.1, and yeah, I'm gonna start some breakout rooms. Okay, what I'll do is this lab is also on Canvas actually, so I'm just going to stop sharing. And I'm going to open some breakout rooms. So yeah, I think anybody who's still having issues with prompt sync, don't worry about that and just don't use it. Just have instead of prompt sync, just just explicitly put the what you want the user input to be. I will also post the lab question. So I'm going to post a screenshot of the lab question in the chat. There will also be the lab questions also on Canvas. So you can check that there. All right, awesome. So I think what we're going to do for this lecture is we're going to change things up a bit. So for this lab, instead of having like an hour, I think 30 minutes should be good, just because we did show like another example that's super similar to this one. And if there are issues with prompt sync, that's okay. Just assign the user input directly using variable assignment. All right, so I'm going to start taking people to breakout rooms.
Thanks.
Hello, is everyone assigned to bracket rooms?
I think just the one who has a question, just assign them.
Okay, thank you. Because I don't see any prompts showing which bracket room I should join.
All right, let's see. So, okay, of the three people, because I'm not sure if the order is right. So I see Hassa as being first. So I'm gonna, okay. Let's head to room 1. All right, so I remember seeing Kamal is next. So Kamal, let's head to a breakout room. All right, I see Helen has a question, so let's head to a breakout room. All right, I'm just gonna take the first person I see to the breakout room. So that will be Yihan. All right, I don't see any more hands raised. How's everyone doing? Good, done. Okay, awesome. That's awesome. Okay, anyone who has issues, feel free to raise your hand and we can head to a breakout room and take a look at that. I also should say if the prompt sync is not working, that's totally fine. And you can just like not use the prompt sync and just directly put the user input in.
Alim, I just have
Oh.
a question. The prompt, I should install it on the folder that I work on it or the whole directory?
It's going to be the folder where you work on the project.
So it's gonna work
But
for
anyone
all
who
of
has questions, do raise your hand and I'll try to get to everyone in order. So Najla, okay. Head to the breakout room.
Yeah, it's just for these people who don't know how to uninstall the file, they could download this file. They just need to unzip the file because it have like multiple file in it. That's why I put it in a zip format and then paste it in your Visual Studio in order to get the prompt to work for you. Assuming that you know how to put the required code in your Visual Studio.
Thanks, Abdulrazak. Actually, I think in my particular case, my operating system does not support this current node. So they're trying to find an alternate to it.
Sorry, say that again.
My operating system, the one that I have, is an older version that does not support the new node version.
And what operation system are you using?
I'm using Mac OS High Sierra. It's 10.13.6. It's pretty. It's
Not really familiar with Mac, but I wonder if Node does not work at all in your operation system.
No, there is a Node version that is compatible, but I think the syntax to do the input is different, so they're trying to figure that out and probably letting me know.
I'm gonna send you a different way of doing this.
Okay.
You just need to understand the syntax of my code and tell me if this is gonna work for you. Because I do communicate with the council in different ways.
Okay.
So I'll send you that file and tell me if you do understand it, or if you have any question, you could text me in the break.
Sure. Thanks, Jazakallah.
So Abdulrazak, what you are saying, so if I install this file, I don't have to go through that prompt saying thing again and again?
Yeah, you do not need to do that. You just have to unzip the file and then paste it in your file directory in Visual Studio.
Which file directory?
Let me take a screenshot of mine and then I'll send it to you.
And is there any way you can, because I'm using Zoom through my phone, so I don't have the chat open on my computer. So is there any way I can get the zip file?
Where do you want this file to go?
Can you post it on Canvas? Like, is there a way we can do that or no?
I don't think I could do that on Canvas. I could do that on Slack.
Okay, I'm not using Slack yet. Let me go on the Slack. Hold on. Slack. Slack group. Okay.
I was talking with somebody previously. If you can just give me a second, I'm trying to send them screenshots. Just in a sec.
So in first Slack, I need to first create an account.
I believe in a Slack you need an account.
Okay, so my Slack is there now. Yeah. So I'm trying to find you, but
Just drag and drop the file to the
okay.
the VS Code environment, Abdulrazak.
I'm sending a picture of what I have in my Visual Studio at the time being. So on the file directory on the left side, I just paste it over there. And for the code, the necessary code, it is also has been marked in the picture. This is
Yeah.
what you need so far to communicate with the council.
But you don't have to run anything on the terminal.
Oh no, definitely you need to run on the terminal. So the first line in my code, the one I've marked it on the right side, this is telling you the, you know, like the terminal that's you're going to have like input output in the terminal. And then the rest, you know how to communicate with the terminal, like you know how to, you know, like run console log and stuff. So when you run your console log, then things can work. Let me.
I have a weird like error. Once I use node, then the file name, it's worked perfectly. But when I select like specific code to run it and use the Control Alt and N as a shortcut to run the code, it's give me an error. Why?
You cut down. I did not hear that correctly.
Like when I use node on the terminal, let me just show you what I mean. Just a minute, give me a second. Share my screen. Oh, okay, it's there. Just a minute. Okay, can you see my screen?
Yeah.
Okay, and just let me maximize this one. Yeah,
Yeah.
look, I run it on the terminal, like when I call the file, it's already like working perfectly. Just a minute. Yes, and give me like whatever I want. But once I selected, like I want to select this code and just use Control Alt and N as a shortcut to run it, it's give me an error. But once I try it with other like assignment, it's worked perfectly. Like for example, here, if I want to just use it, Control Alt and N, it's give me an output here. Can you see it?
Yeah, I'm scared I cannot answer this question because I don't use shortcut with the console.
Oh, okay. Okay,
Yeah.
no. Okay, thank you.
Just to clarify, I don't use VS Code often. I usually use the community version of Visual Studio.
Uh-huh.
So I'm trying to, you know, get the like myself familiarized with the Visual Code
Okay.
compiler.
Because I use it for Python and now I convert to Java, it's completely like different. That's
Yeah.
why I struggle with it.
Can anyone please share what we need to write in the terminal? So I have written constant prompt is equal to required prompt string, but I believe we need to write something in the terminal. I know Razak that I can download that file before, but if anyone can help me what to write in the terminal in order to run the sync file, prompt sync file.
I could share my screen.
Yes, please.
I just worried the instructor would come back and then he say, "Oh, come on, you're taking my place." You know what I mean? Okay, I'll try to do this fast. So I'm gonna share my screen. Okay, so this would be second screen. Okay, so basically what I was saying is you need to download the file and then paste it over here. If you guys can see my screen, can you?
I can see your screen, but my thing is that I don't have the file right now, so I can leave that. But if I don't have the file, what will I write in the terminal? Like the day he told us before. To write the-
NPM, NPM in it.
I don't remember the command
Can you
myself.
please share? Can you please? Okay, thank you so much. npm install.
But
Thank.
install first init, INIT minus Y or dash Y.
Oh, okay.
Someone Waqas send it on chat. If you can
So
see
this,
on chat.
yeah. This is all I need to write.
Then after you run the first command, you should run the second command. And
Uh,
from
it
Sept.
says npm. It says unknown command init-y. That was not the exact file. Or
Share
was
your
it?
screen. Share your screen. Let's see.
Hold on. Actually, I'm working on.
You open the cam, not the share screen.
Yeah, because I'm not working on the screen.
Okay.
Like this.
Minus n, do you mean this and the minute? Okay, to see the list. I think because you have spaces on your folder name, like they mention it in the first lecture. Once you create a file or folder, do not
No,
put
no, it was fine yesterday. It was working fine yesterday. And but I don't like this because every time when you open new terminal, you have to write it again. So so I'm not sure what and okay, what I need to write in it. Let me.
Guys, I've mentioned I'm going to send a JavaScript file for somebody who is having difficulty to communicate with the terminal. And I said I have an alternative way. Who was that?
Hi, Abdul Razak. If you don't mind, please help me to uh, install the what kind of for that prompt sync, what kind of extension we have to use, because I missed the yesterday's. I couldn't come up with that.
We did not use any extension. We download the packages for the files. So there is two ways you could download the file using the command line. I don't remember them myself. Or you could just like copy paste the file I shared in the file. It gives you the same result.
Copy means you are sharing somewhere in the chat box.
Yeah, I'm gonna make a reply to my file. Maybe you can see it. It's gonna add here. Can you see it now? Maybe I
Just
can share it
a
again. In a second.
All right, so I think what we're going to do now is, if everyone's, I think we spent a good amount of time in the lab. What we're going to do now is we're going to take a, let me just check our, double check our.
Okay. Yeah, I got it.
So we're going to take a 10-minute break, and then we'll come back and we'll start loops. So I'm noticing, yeah, there was a, I guess some people here might have been talking about like node or like setup. When it comes to setup for the prompt, I'd say don't worry too much about that. We will accept assignments that are not using prompt, and they just where students just explicitly give a value as user input, like 5, for instance, right? That's totally fine. We can explain prompt more in depth during the office hours from 7 to 8 today. And what we're also going to do is we will set up a Git repo with everything you need to complete lectures and labs. And that'll have like, we'll also have some instructions there on how to get the packages set up. So you can start coding right away without having to worry about, package setup on your own right now. So that's something that we will cover. Yeah, let's go on break, and we'll be back at 10:18 to continue with loops. All right. I hope everybody had a nice break, got a stretch. Let's get started on loops. I'm going to share my screen. Can everyone see my screen? Perfect. Okay. Not, no. Nice. Very good. Okay. So let's talk about loops. So I think before we start talking about loops, what we are going to do is just talk about sort of repetition in daily life as an introduction to loops. What are some examples of this? So, automatically, and, feel free to type in the chat other examples that you can think of. But washing a stack of dishes one at a time, an example of repetition. You can think of this as like sort of a loop where, while you have dishes, you wash one, that dish is washed, now you have another, okay, that's washed, and so on. Any other examples of repetition? Turning pages in a book. One more. Taking a shower. Yeah, I guess so. Yeah, from like one day to the next. That could be example of repetition. Turning pages in a book. It's like a book. We have not good at drawing books, but that's like our book, and we're just turning one page, two, three, all so on. For sure, eating a meal, like one meal we have something to eat, and then the next day something else, and so on. Although hopefully you aren't eating exactly the same thing every day, but it's totally fine if you are. Cooking, yes, for sure. Cooking is also a good example. Like have it when you're slicing onions, and you're one slice, two, three, and so on. That's one example. Yeah. All right. So let's actually think about code though. Let's think about what happens when we don't have loops. And I'll give an example. Oh yeah, packing lunches for your kids' assembly. That's true. So let's think about this. How might you count from 1 to 10 using console logs? So like, so we'll comment this out and let me move this code a little bit down. If I want to display console 1 through 10, like I literally want to have one line that's 1, 2, 3, and so on, right? So I want to have like, right? How would I actually go about displaying the numbers 1 through 10 on my console? Just using console logs. Probably going to get pretty repetitive, right? Console log 1, 2, 3, and so on. Let's just do up to 4, or let's do up to 5. And then when I run that, okay, like it'll print, but it's pretty tedious doing this. No, you don't do, not console loop, just using console.log, right? So if I use console.log, I have to just repeat my input again and again and again and again. Now this is really tedious. It's especially tedious if someone asks you to print out like the numbers, 1 through 1000, just using console logs, right? Because then you just have to keep doing this 1,000 times. Take a lot of time to do that. So we're going to introduce loops as a way to solve this issue. And what we're going to start with is a real world example of just thinking about the anatomy of a loop and how to start off the loop. So to do that, there are 3 steps in a loop, and I'm going to use a example of trees or of someone who, let's say we have a gardener who works in a sort of a garden that has many trees, and this gardener is picking fruit from these, let's call them apple trees, right? So I have 1 tree, it's my really bad impression of a tree. I have 2 trees. I have 3 trees. I'm only going to have 4 trees. Okay, and these are apple trees. So let's draw some apples here. This is 1 apple, 2 apple, 3, 1, 2 there. Maybe like 4 apples on this tree and only 1 apple on that tree. All right. So there are 3 steps to a loop, and we will use the tree example to start with this. So our first step is what's called initialization. It's the starting point of our loop. So in this tree example, the gardener is going to start with this tree. And let's say this is the 0th tree. We're not going to use first. We're going to go use 0, and this will come up later. So let's just call it the 0th tree. This is the first tree. This is the second tree. From here to here, here to here, and then the third tree is here. But I'm just starting my count at 0 instead of 1. That makes sense. So what we call initialization is the starting point. So that we're starting at the 0th tree. And another thing to think about in a loop, in this anatomy of a loop, is the stopping condition. So that is, when do we stop our loop? In this case, we'll stop our loop when we are at the 3rd tree, because this is our last tree. So this is when we stop, and this is when we start. What's changing from tree to tree, other than the number of apples, is the increment, or rather, it's what we call the increment, which is which tree we are on. We start on the 0th tree, then we move to the 1st tree, then the 2nd tree, and then the 3rd tree before we stop. So this process, this is called an increment. So we are incrementing which tree we are on from the 0th tree to the 3rd tree. Is that clear? Perfect. Now let's actually turn this into code. And why not use this tree example? So I will first write the code here, and then I'll open VS Code and actually I'll go more into it. But I think I'll first have the code written out here, and I will highlight each of these and just show, which part of the code corresponds to the start, the stop, and the increment. So let's do that. The syntax of the code is going to start like this. And I will say we want to stop at the 3rd tree. And don't worry, I will explain exactly what's going on here. And let's just make that white so it's a bit easier to see that. All right. So let's talk first about our start. So I will use green for start. So this loop, this is the structure of a loop, and what it's doing is it's saying we are going to start here. We're going to start, and we're actually going to use a variable I to represent our start. And our start is I equals 0. Then we are going to continue until, in this case, it's going to be a condition. We're going to continue as long as I is less than 4. And I think most important of all, each time we proceed through this, we add 1. What I will do is I will actually, I think with this tree example, let's actually make a table just to see what's going on a little bit internally here. So this is a table, and I'm going to use the table just to represent these values. We're going to have I less than 4. And then what I'm going to do here is I'm going to do I equals I plus 1. We're going to think about how the computer goes through this loop. So what the computer first does is when it sees this, it's going to say, okay, we're going to start at I equals 0. So we're going to start there. Is 0? So let's just stay with this. You can also do that, but I'm just putting I equals I plus 1 for this increment just to make things a bit more explicit here. We're going to start at I equals 0. This is in our table, and this is actually how the computer is also sort of doing it. We start at I equals 0, and then we're going to check this endpoint. We're going to check our stopping condition. Should we stop the loop or should we not stop the loop? Is essentially what we're asking. And the condition we use to check this is I less than 4? Is I less than 4? Is 0 less than 4? No. Or sorry, it is. 0 is less than 4. So we will continue this loop for now. So if that's the case, now we console log. We are at tree 0. Kind of like this gardener here. The gardener is at the 0th tree. So we are at tree 0. Is that clear? How we sort of do that? We first initialize. I is initialized to 0. And then we check, okay, is 0 less than 4? Yes. So we can stay in the loop. We will actually print this out. So this is what we're printing out as long as this condition is true. Yep, you can initialize I as 1 as well. But in this case, we're going to start at 0. Because often in programming, we use a 0 as our starting point a lot of the times. Okay, that's clear. Now we're going to go to this point, I equals I plus 1. So that's what happens once we're done running what's inside. Exactly. So after we're at tree 0, this I is going to be incremented by 1. And so now it becomes 1. And then once we've run that, we go back to the start. That's this idea of a loop. We're repeating it, right? And so when we repeat it, this I is 1 now in the table. And now we're going to check. We're going to do this again. Is 1 less than 4? Yes, that's true. So we print that out. We're at tree 1. No, we're not printing out I equals 0. Printing is specific, like console logging. This is what's being printed out here. Every time we are allowed to remain within this loop, and every time we loop through this, we are printing this. Yeah, until 3. We will get there. So what does everyone think is going to go here? Exactly. This is going to be 2. All right, good. And then, so now we're at 2. We're going to go again into this loop with I equals 2. Is 2 less than 4? Yes. Perfect. So then we print, we are at tree 2. And then this 2 is incremented to 3. And then we have 3 again. 3 is less than 4. Exactly. And then we update 3. We don't stop yet. We update 3 to 4. And then now here, this is 4. 4 is not less than 4, so we stop. And we do not print we are at tree 4. Exactly. I think one good thing to mention is that this assignment only happens in the beginning. You can almost think of like this sort of steps outside and okay, I is 0. And so every time we go through this loop, this is updated. So I is 0, and then here I update it to 1. And then on my next time I check, okay, then we do these checks. Is 1 less than 4? Yes. So I print that. I update 1. 1 is now 2. Is 2 less than 4? Yes. We print that, and so on. Until we hit 4, actually. Is 4 less than 4? No. So then we stop. Perfect. All right, so does anyone have any questions about that? We're going to go into a few more examples of this on the following slides. All right, seems like everybody is, oh, okay. Bilal, how can I help?
So when it goes through the let I equals 0 and then it says I equals I plus 1, right? Does the loop not restart at the beginning where it says let I equal 0? So like doesn't that just reset?
That's a good question. So it does not reset. So this
Why?
bit that I have here, this I equals 0, that bit is only initial, the variable is declared and initialized as 0 once. And then you can almost think of this sort of section that I'm highlighting here. Following that, this is sort of what's done after that. So this is the initialization, and then this is the condition that we check every time before we execute any code inside of this loop. And then when we're done executing code inside, we update the increment before we proceed on our next run of this loop and checking that condition again.
So the let only gets checked once.
Instead of checked, I would say declared and initialized once.
And then
it
the
gets
console
updated.
just sort of forgets it?
It doesn't forget it, because notice how this I is being compared with the 4 here on every other run. So it's the variable is declared, it's initialized as 0, and then every time we go through the loop, before we go through the loop to decide if we should, we check it in our condition, and then in the increment section here, we are updating that value.
Okay. So okay, I think I get it.
Okay, awesome. We'll go through more examples, and we will also make more of these tables as we go through it.
I think I just need a minute to get my wrap my head around it.
No worries. Okay, I see someone missed the starting part. Yep. So this example is also going to be the same thing. So, yeah, let's get started. All right, so let's see. Let's do our table again. And I will need everybody's help to fill out this table. We'll just put I plus 1 there instead of I equals I plus 1. Okay. I will even color code. So yeah, where do we start? What are we going to put at the start for I? Exactly, 0. Good. Is 0 less than 5? Yes. So we put true. So what do we see in our console now because 0 is less than 5? We don't see 1. We're printing I, remember, right? So we see 0. Good. So I will even, I guess, let me see if I can fit this in. This is what we print to console. Actually, you know what? For now, that might be a bit confusing with this here as well. So I will leave that out. Okay. Once we print that, what happens to I? How does I change? Yeah, it changes to 1 because we're adding 1, right? This increment. So this becomes 1. What's the next value? So we went through our loop once, and now we're back at the start again, and we're checking our condition. So what's the next value of I? Exactly, it's 1. What about, is I less than 5? Yep, so true. It seems like everybody's got this. So true, 2, 2 is less than, yep, exactly, true. And each time we are printing, we're printing in our console that this is what it is, right? This is 3. So on our next run, when we start the loop again, 3, true. This is 4. So on our next run, perfect, we have 4. This is true. 5, right? And now on our last run of the loop, I is going to be 5, but 5 is not less than 5. So that's false. So we end there. We do not print 5. Exactly, we stop. Yep, so in the first iteration, we will print 0 because we're going to start at I equals 0. Here, 0 is less than 5. So this condition decides whether or not we will run the code inside the loop. Because this condition is true, we are going to run this code. And then when the code is finishing running, we will increment, as you can see here, we will increment I by 1. So I becomes 1. So on the next run of the loop, I is 1, true, and so on, and just like that. Exactly, the console will print, well, the console will print 0 to 4. So let's actually go through an example. As you can see, and right, like now I don't even need to worry about, I don't need to write separate console logs for everything I want to print. Now we have a loop that has its own internal logic, as explained, that prints out these numbers. And, if I want to, actually, yeah, here's a good question. Exactly. What should I change here if I want to print the numbers 1 through 10, including 1 and 10? Good. I starts at 1. And what should I change this to if I want to print the numbers 1 through 10, including 10? Okay, if I make this 10, what happens if I make that 10? Am I going to print 10? No, I'm not going to print 10 if I do that. I see someone here put 11. That's a good idea. Let's see. Let's try. I think 11 will work. Perfect. So now I have the numbers 1 through 10. Or yeah, I can also do less than or equal to 10. That's good. Because less than or equal to is true when 10 is less than or equal to 10, because 10 is equal to 10. That also works. Yep, exactly. All right, so that's going to be, so does everybody get this example? Like this idea of the for loop and this counting up example? Awesome. Oh yeah, my bad. So I put plus plus here. That is exactly the same as doing this. That's just a habit of mine, writing that. Sorry about that, but it's exactly the same as writing plus plus. So I'll just write it here. I plus plus is the same as I plus 1. So those two things are equivalent. So the loop prints 1 because our starting point is now 1 in this example. Because we want to print the numbers 1 through 10. So that's why it's printing 1. It's not starting at 0. Because now our starting point is 1. Yeah. No. So this increment happens at the end. This increment, like this bit here, this happens at the end of this execution. So I see someone saying we always have to put the number after it in order to get the number. Yeah, that's a good convention. I would say it's more important to think in terms of if the number you want to get is 10, what sort of condition can you put here such that when it's at 10, it's still true, so it prints that number. 10 is less than or equal to 10 is true, so that works. Yep, the console prints before increment, or more generally, any code that we have in this block is going to print before the increment happens. So it's almost like the first thing that happens is sort of we have our I, we initialize that to 0, then we check, is I less than 5? If it's true, we print the code block, and then we update I. I will actually, yeah, we update I, and then we go back to the beginning. Now, the first time we run through this is where we're setting I to 0. After we have done that, we don't actually set I to 0 anymore because I already exists as our loop counter, basically. And I should also put here, if it's false, if this is false, we stop. And this code block that I have here, this code block is basically this. It just so happens to be a console log. All right, is that clear? Okay, awesome. I see some details about like, why do we put the increment statement? So like, these are more implementation specific questions. There are other ways you can write loops where this is actually inside and you can actually not have that there, but that's something we can worry about later. This is the standard format or syntax for a for loop. Yep, Sawa, I see you have a question.
Yes, Salim, I was wondering, can you repeat again the different scenarios in which we would set initialize to 0 and when we wouldn't? Because when you showed us the code on VS code, you have it as 1, I as 1, but then you
Right.
also said to initiate to 0, so initialize to 0. So can you explain the difference?
So it depends on what we want to do, basically. In this case, I want to print numbers from 1 through 10. I don't want to print 0. So a way to make that easier for myself is just to have this thing start as 1 and then just have this check be less than or equal to 10. So then it'll print 1 because 1 is less than or equal to 10.
Right.
And then it's gonna continue with that. All right, so Dawood just type something in the chat for the for loop. Okay, I would say that is good, but do not erase and like that sort of stuff. We're going to be covering that later, so don't worry about that right now, like what that means for anybody who's looking at that and wondering about that. Yeah. Okay, awesome. Our next example is going to be counting down. So remember on the last slide, this was a plus. Now we're actually going to do minus, and it's exactly the same logic. So what I'll do is I will draw out the table, and I want everyone, let's see. Okay, so I will draw out the table, and I want everyone to help me fill this out, and we can think about what is going to get printed. All right, so where do we start? What is the starting point for I in this case? Exactly, so we start at 5. Is 5 less than 0? So I actually made a typo here. This would just change that to greater than. Otherwise, there will be a big issue. We will cover that later. Yeah, so we're just going to change that to I is greater than 0. Is I greater than 0? Yes. What is I minus 1? 4. Perfect. And you can sort of, it's a very similar process. The next time when we start with 4. 4 is greater than 0. I minus 1 is 3. 4 minus 1 is 3. So yeah, what will our console look like when we do this? So the first line is going to be 5, right? We're going to print out 5, and then we print out 4, right? And then, exactly, so now we have 3, because the next iteration of our loop, 3 is greater than 0, that's true. Now we have 2, 2 is greater than 0. Now we have 1 is greater than 0, 0. Now 0 is not greater than 0. So here we stop. Exactly. And what will our console look like? I saw some. So 5, 4, 3. What comes next on our console? Exactly. 2 and 1. And there we stop. We do not print out 0 because this is a greater than, and 0 is not greater than 0, so we won't actually end up printing out 0. Exactly. All right, let's think about this example. What happens if we do this? This is going to be a fun example. All right, so how should we start this? 0, perfect. 0 is less than 5, true. I'm just going to put t. I minus 1, what's 0 minus 1? No, what? Yeah, minus 1. 0 minus 1, minus 1. Okay. So I is now minus 1. What happens now? Is minus 1 less than 5? Yep. Now minus 1, minus exactly, right? Because this will keep getting more and more negative. This will always be true. Like this thing will just keep going. It will not stop. Exactly. So let's actually do this. And I hope this doesn't break my, I don't think it'll break my computer, but I will have to shut it down. And let me just see. So I was, as long as I is less than 5, I minus 1. This is exactly, this is a real loop. Oh wow, look at that. So it's just going and going and going. So I have to cancel that. Exactly, yeah. This is it's a fun example. Definitely got to be on the lookout for. So this is why it's really important to know these conditionals and to be able to understand that, because maybe a bug could come up with it in your code where that happens. Yes, Abdul Razak, I see you have a question.
So on the previous example, did we hit an infinitive loop?
For this example, this one?
Yeah.
Yes, so this would keep running. This would never stop.
Is this going to crash the system or something?
No, it'll keep going. I mean, it's not crashing my computer, see?
Oh, okay.
Yeah.
Okay.
So to break the execution, I just, my terminal selected, and I just hit Control C, and that kills it.
Oh, okay.
Yeah. It's almost like you can almost see how fast your computer is running if you think of the time it takes that you see something here. And anyway, that's not something we're going to get into, but as you can see, the computer has a very set speed, right? Because it's only doing so much of this at a time. It's not instantaneous. It seems instantaneous when we're not in infinite loops, but you can actually see these numbers being printed out. So there is a set speed at which the computer runs. Or before that. So this for, that's just a syntax for a for loop. So that is just how we structure it. We have for, and then in these brackets, we will have our initialization. So this is what we start as. This is the condition that has to be true for us to execute the code block here. And this is how we increment or update our initializer, I, every step of the way. Can you have more than one condition? Oh, absolutely. Like you can, this is the condition. You could definitely make this more complicated. You can introduce like and like all the stuff. It's just a standard. Can you make a loop for a random number? Yes, you can. I won't do that right now, but I can. That's something you can definitely do. You can have like something that is always checking random numbers. And you know what? Let's yeah, we can do that another time. But I think I'll leave that as an exercise for you guys. All right, so let's see, what do we have next? Okay, so let's take a 5-minute break. I think that's pretty good so far. So let's take 5 minutes. We'll come back at 11. And there are a few more things we will cover before we get to our lab. So you can do the increment. I'm pretty sure you can do the increment inside the loop, but for now, just use the syntax that we give you. Yep. Helen, I see you have a question.
I typed out the loop and it's not working for me.
Oh, okay. But I guess we can cover that in lab, but do you understand like the concept of the loop and like what we're doing here with the table and how it's working?
Yeah, I understand that.
Okay, awesome. So we'll take up that sort of stuff individually during the lab. But yeah, let's come back at 11 and we'll continue a bit more with loops. We'll expand on these concepts we've introduced. All right, welcome back, everyone. Let me share my screen again, and we can continue with our loops lecture. There's really not that much left. We're going to cover 2 more examples, and then before we get to the lab, I think you guys will like those 2 examples. Can everyone see my screen? Awesome. So now we're going to think, what if we put I equals I plus 2 instead of 1, right? Because it's just an increment. We can change that. We could even make it multiplies. I will actually do exactly right. So it skips by 2. Perfect. Why don't we do that on a table here? And obviously, it's going to change how many times this prints. So, I would recommend when working with loops right now, writing this table out. Because I remember when I started coding, this is actually what I would do usually every time. Especially when, this gets more complicated when you're dividing or multiplying. It's very useful to do to actually write this table out. So yeah, I plus 2. So good, we start at 0. 0 is less than 5, that's true. 0 plus 2 is 2. Now we have 2. 2 is less than 5, true. 2 plus 2 is 4, good. 4 is less than 5, true. 4 plus 2 is 6. Is 6 less than 5? Yeah, good. So now here we stop. And so what is the console going to print? This is our terminal here. So what's our console going to print? Not quite. It won't print 6. We're going to print 0, 2, and 4, right? Because this bit of code here, this bit, I'll actually put this in red. This section of code and this are like very closely tied. And the idea is if this is true, then we can actually go inside and print this. So 6 is not less than 5. That's false. So this block will not execute. The loop actually stops right there. So yeah, in this, we print in this order 0, 2, and 4. Awesome. All right. So with that example out of the way, now we're going to talk about loops within loops. And I think a good way to start this is to talk about the time, specifically clocks. So here we have our clock. And, we have different hands, like we will have the hour hand. So let's say 12, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, right? Exactly. We have the hour hand. I think it's a smaller one there. I have the minute hand. So the hour hand is like a loop, right? Because it's sort of like going all the hours. We have the minute hand. It's all the minutes. So right now it's 12:10 or 12:05. And then we have the second hand, which is like actually counting the seconds, and that's another loop. So it's almost like there are loops within loops, right? Because you can think of it as a nested loop because it's like once the minute hand completes its full, once this yellow bit completes its full rotation around the clock, the hour hand will move by 1. And then once the second hand completes its full rotation, the minute hand will move by 1 minute. Exactly. So now we're going to take this example and we're going to turn this into code. Not the clock example specifically, but we're going to think about a multiplication table. And what we want to do is we want to find out the multiplication table from 1 through 5. So I will actually just draw a table first. Have 1, 2, 3, 4, 5, right? So this is almost like one of these loops, 5. And then we're first going to do, let's first do for 1. So 1, it's almost like this 1 is going to loop over each of these. So 1 times 1 is 1, and then 1 times 2 is 2, and 3, and 4, and 5, right? Now we're at 2, and now 2 is going to loop over each of these. 2, 4, 6, 8, 10. Exactly. Now we have 3, and and so on until we get to 5, our end, where it's going to be 5, 10, 15, and so on. So I hope that is that clear? Sort of, we're going to try to take this multiplication table and turn it into a loop within a loop. All right, so let's think about how to do that. So multiplication table 1 to 5 within a loop. Obviously, we're going to have an outer loop, and we want to start at 1. So we start at 1. I is going to be 1. What should our condition be? Remember, we want to include 5. So no, we won't have and 5. And that means something else. So the condition is specifically, we need to say some operator with 5. Let's make it 5. So I see less than or equal to. Yeah. So and 5, that's yeah, that means something else. Let's see. Okay. Yeah, we could also use I is less than 6. That's good. But I'll just put 5 there because yeah, it's up to 5. And then we'll say I is I plus 1. Okay. That's sort of like we have covered this bit. But now we need to find a way to represent another loop where, and I think this will be more clear once I write this out. For each value in the outer loop, we will loop over 1 through 5 in the inner loop. So I will write it down, and I'm going to use, it's better if I just write this out first, and then I will explain what's actually happening here in terms of the, exactly. So I'm just using J. J is going to be, because we've already done I, so J is going to be a bit different than I. So how this actually executes is that, I think one good way to think about it is that, remember that I mentioned as long as our condition's true, we run everything inside, right? Everything that's inside gets run. So when I is 1, 1 is less than or equal to 5, yes. So then we run all of this full loop with J from 1 through 5 with that value of 1 in hand. And when that's done, when that iteration's done, we go back to the start and we say, okay, let's add 1 to I. I now becomes 2, and we just repeat that whole process. We run everything inside from J is 1 through 5 with I equals 2. If I console log, if I want to show multiplication, I would say that I times J is equal to, just like that. Let's see what this produces. Let's see. So 1 times 1, right? Because remember I mentioned we're going to start with 1. And actually what I will do to make this a bit clearer is I will just adding some spaces so it's a little bit clearer to see each run of the loop. And I will say So we'll do that. Okay. So this is where we're starting. So we have that 1, I is 1. And you know what? I will even do this. Sorry about that. I is, and then here I'm going to say J is, okay. So we can actually go through this every step of the way, what's happening inside. Perfect. So we start off, I is 1. 1 is less than or equal to 5. That's true. So now we're going to run everything inside here. So we're going to, it's going to console log that I is 1. Now we're going to start the inside. Now we're going to actually start this loop. The loop starts with J being 1. 1 is less than or equal to 5. Yes. So we're going to say J is 1, this bit. And then we console, we because that, 1 is less than or equal to 5. So yeah, J is 1. And then we have a console log here where we're going to say 1 times 1 is equal to 1, right? Then we go back to the start of this loop, this inner loop, because this is still a loop. And we did increment J to 2. 2 is less than or equal to 5. So we say J is 2. And then I, which is 1, 1 times 2 is 2. And then as we see, J is 4, J is 5, and so on. So that's our first, so that's us taking 1 and multiplying it by all numbers from 1 through 5. And of course, we print this, we start a new line. And so that is, all of that is happening inside of this, the for loop that's outside, for I equals 1. And then what we're going to do is we increment I to 2. And then we start again. I is 2, right? Here, I is 2, because 2 is less than or equal to 5. So we can execute all of this. And then we start this loop again with I equals 2. So again, J is 1, I is 2. 2 times 1 is equal to 2. J is 2, J is 3, and so on and so on. Exactly, right. So because it's almost like in this loop, if this condition's true for I, we're going to execute everything inside of this for loop, so all this code here, for that value of I equals 1. So then all of this runs once for I equals 1. But since we have another loop here, from J is 1 through 5, for that I equals 1, now we're going to have this loop running, 5 times with I equals 1, which is what we can see here, right? Because we have 5 of these print statements, 1, 2, 3, 4, 5. Make that a little bit bigger. We have 5 of these print statements, 1, 2, 3, 4, 5, for I is 1. And then from J is 1 through 5. I hope that's clear. Does anyone have any questions about this idea of having like a loop inside of a loop? Right, that's a good question. So we won't be using it for this lab, for this noon lab, but this is an example of where it's being used for a multiplication table. There are many others. There are countless other places where it's going to be used. Yeah, J is a second loop, right? Usually it's like, I'm trying to think, if you have a lot of data that you want to work with and you want to, for each, you want to repeat some sort of processing for that data repeatedly, and then maybe like inside of that you have more things that are happening. I know it's a very abstract example, but rest assured, these loops within loops are indeed used. Line 58 for sure. So this is just like, I just put this in just so there would be a space here. A space here, just so we could like go from one run to the next. Yes, so that's not this double while loop, double for loop. There are other loops we'll use for gaming, but certainly, I mean, there are many games where I'm sure that loops like these are being used internally. I can't really think of like a very specific example, but I know that 3D gaming, where each loop is like, let's say, a dimension in this like in some 3D grid, and they want to maybe go through this and like put things into something that's like a 3D representation of the game. Let's say they want to put sprites or other things in, but I'd say not to worry too much about specific examples, but just to understand the concept of how this is working. Yeah, awesome, good question. Does anybody have any other questions, like specific to the loop and like why we're getting these things printed out and stuff like that? Or is everybody's feeling okay about this? Okay, awesome. All right, so what I will do is now we can do a 5-minute break. And yeah, what I will do is take a breather, stretch a bit, and then get started on this lab. So you're welcome to start early, for sure. I will send a screenshot, but this is also on the Canvas. So this lab is also on Canvas. I will send a screenshot. You're welcome to start working on it now, but we will make breakout rooms for if anybody has questions, starting in say 5 minutes. Yeah.
Sorry, Alim. I was referring to the code, the VS code that you're working on.
Oh, for sure. Yeah.
Yeah,
I will
thank you.
I will also I think during the lunch break I'll also just write out like these examples and I'll just post the file as well.
Okay.
So actually, yeah, I will write out during lunch. I will write these examples out in more detail, like everything that we covered for this lecture, and I'll put that on Canvas, the JavaScript file. But
Okay, thank
I will send a screenshot of I think what might be
thanks.
easier is if I'll just copy paste this into chat. Let's see. Yep, Hannah, I see you have a question.
Yes, I just want to clarify for the lab. You want in the first question to just print the total summation from 1 to 9, or just like the increment step by step? Once
So
I
calculate the sum of numbers from 1 to 10, so including 1 and 10, and then print that calculation to the console.
Yeah, but I mean, you want to print it on the console for the final result, or step by step printed on the screen?
Oh, you can do both. I think it would be pretty awesome if you were to also show step by step, like
Okay.
how it's adding, and then also say, the final result is this. Yeah,
Oh, sounds good. Okay.
sure.
Thank you.
Yeah.
I'm gonna do that right now. I was about to write.
It's on Wednesday and Thursday.
Mhm.
Do you think you'll be working?
All right, so we're gonna make some breakout rooms just so we can take myself and my fellow instructor can take students who have questions about labs into breakout rooms and we can explain that. But yeah, feel free to start working on the lab. We'll actually close all rooms and then I'm going to open all of the rooms again. All right, so I see Awab has a question. Okay, I'm going to take you to breakout room 1. I think for now I'm going to stop the recording, and just in case there is a tutorial that we cover in the main room, I can start the recording again.